Hey grade 9s, just making a video as a sample to show you what yours might look like. I'm going to use paper for my video, but if you wanted to do something on the computer or something a little different, feel free to do whatever works for you. Just a reminder that we did go over periodic table trends, so I will be referring to this periodic table that we used for our previous assignment. The first compound that I'm going to go over with you guys is our Ionic compounds, and on my rough draft, which is also Google Classroom, and you guys should also have your own. My first one for my rough draft is sodium chloride, so I'm going to go over that one. So our chemical name is sodium chloride, so I'm going to write that here. Sodium chloride, and our chemical formula to find it, if we look up sodium, the symbol is Na, so I'm going to write Na for sodium, and chloride is actually referring to the chlorine ion, and that is right there, so the symbol is Cl. So that's our first step. Moving on, we're going to create some Lewis diagrams for sodium and chlorine, for sodium chloride. And so what I'm going to do is have this for sodium right here, and this one is for chlorine right here. And once again, we're going to be referring to our periodic table. So just a reminder, if you wanted to, just a quick way to find out the number of valence electrons, you could look at your assignment that we did for last week, but you could also look here. If there's an element in the first column, it has 1 valence electron. If it's in the second column, it has 2 valence electrons. We're going to skip the transition middles for now. We'll get back to them in a future lesson. But if you go from columns 13 to 18, the rule is, I'm going to write it down. It's right here. The rule is drop the 1. So that means the 13 becomes 3, the 14 becomes 4, 15, 5, 16, 6, 17 becomes 7, and 18 becomes 8, with the exception of helium. So our nonmetal right here is chlorine. If we search chlorine, it's in the 17th column, which means that it has 7 electrons, because once again, we've dropped the 1. So I'm going to draw 7 electrons on chlorine. Remember to draw them single before we pair them up. So I'm going to draw 1, 2, 3, 4, 5, 6, and 7. Because once again, remember it's in the 17th column, we dropped the 1. The sodium, I forgot to draw it, but it's in the first column, so I'm only going to draw 1. And right now, I'm going to draw it right here. So that kind of side by side. So that's the first step. Draw the Lewis diagrams for the atoms. The second step is to show our ionization step. So what ionization means is that when elements have their valence electrons, the goal is to have a full electron shell. Right now here, sodium is not happy. Sodium's sad. Draw a sad face. And chlorine's also really sad because they don't have a full shell. Sodium really wants a full shell, and so does chlorine. And they're also going to do whatever's easiest. So in general, most elements want an octet. An octet means they want 8. And so it's easier for sodium to lose this one than to gain 7 more. And it's easier for chlorine to gain 1 than to lose 7. So they're going to do whatever is easiest. There are some exceptions. So for example, hydrogen has 1 and helium has 2, but that's just because they're in the first column. But for the other ones, we're going to assume that the maximum is 8. Okay, so let's move on to our ionization step and see what happens. So like I said, this is our sodium, this is our chlorine, and sodium really wants to lose this electron, and chlorine wants to gain 1 electron. So we're actually going to have it transfer over here, and then both of them are going to be happy. However, if electrons are gained or lost, that will result in a charge. Note for you guys, I'm going to write here is that electrons are negative. And so when we lose an electron, we lose something negative, we become more positive. So in order to lose this one, we don't call it sodium anymore. We call it sodium ion. So I'm going to put it in brackets, Na, and in brackets, because it's lost one, and electrons are negative, it's lost one, so it's become more positive. So I'm going to call it Na1 plus to show that it's an ion. And chlorine has gained one more electron. And remember, electrons are negative. If it gains one, it gets a negative charge. So I'm going to write chlorine in these brackets right here and write 1 minus. So that's our ionization step. And then one other kind of random side note that, sorry, it's a really bad chemistry joke, but I'm going to tell you guys anyways. There's also a name for ions. So ions have a charge. And they have a charge because they've either lost or gained electrons. There's another term for ions. So we have positive ions and negative ions. Positive ions right here are also known as cations. And negative ions, like this one here, are also known as anions. And I have a really bad chemistry joke for you. Cations, if you ever forget which one is positive and which one is negative, cats have paws, so cations are, positive. And I don't have like a really bad chemistry joke for this one, but anions, you can think of A for A, N for negative, and ions just for an ion. Okay, so those are a few terms. And now that we have these two ions, a cation and an anion, our next step is our ionic bonding. And something we know about these is that opposites attract. And so we'll have, just going to draw these again. 1 plus and 1 minus. And opposites attract, and these numbers balance out perfectly, so we're good. And I'm also going to draw my valence electrons there to show you, to remind you that we have a full valence shell for chlorine and a full valence shell for our sodium. So what sodium has done is it's lost an electron here, and basically it's become like its closest noble gas, which would be number 10, which is neon. So the valence shell of sodium is going to just look just like neon, and chlorine will have a valence shell that look like its closest noble gas, which in this case is argon. So let's draw that as well. So the bonding here, this is nothing, and this one is completely full. The bonding step. And then finally, our ionic compound, we can just write them together. Here, I probably should have drawn them a little bit further apart just to show that, like, they were apart. And then opposites attract. And now they're together, and we have this compound sodium chloride. Okay, so that would be it for ionic bonding. Let's move on to covalent bonding. So with covalent compounds, remember I made you guys act this out last time? For ionic compounds, we have a metal with a non-metal, non-metal, ionic. With covalent compounds, we have two non-metals. So non-metal, covalent. Sorry, you can't really see my arms. But we're gonna do another example here, and we'll be using water as our example. So for our next compound, our chemical name is water. And a chemical formula is H2O. So another name for water is actually dihydrogen monoxide. Di because there's two hydrogens. And mono for one oxygen. So dihydrogen monoxide. or just H2O and water. Okay, so our next step is to draw Lewis diagrams of the atoms. We have hydrogen and oxygen. Once again, remember, just take a look at what column they're in. If they're over here, drop the 1, and that will tell you the number of valence electrons. Valence, and I'm going to write an E with a minus to remember electrons are negative. Okay, so here for hydrogen, we have 1 because it's in the first column. And for oxygen, it's in the 16th column. So I'm going to draw 6 valence electrons. First, reminder, first of all, draw them single, 1, 2, 3, 4. And then I'm going to move on and draw 2 more, 5 and 6. So I have the 6 valence. So what's happening here is that both of them want to have a full shell. In this case, oxygen really wants to gain 2 to fill up these spaces right here. And hydrogen wants to gain 1 more to fill up this one space here. Remember, there's 2 exceptions to the octet rule, hydrogen and helium, because they're in the first row, they only need 2. But for the rest of them, we can assume that they need 8. Okay, so let's move on. So for our next step, it's our covalent molecular bonding step. So as I said before, both of them need extra electrons. So in this case, because they both need extra electrons, they're going to share. So previously I drew them like this, with 6 here and 1 here. However, right here, if I join them, it doesn't have anything to share, so I would have to join them this way. So what I'm going to do is I'm actually going to redraw it like this instead of like this. It doesn't really matter where they are, but I don't really want to draw my H this way, so I'm just going to draw it like that. And then we're going to pretend that they share. And so right here on my papers, these are overlapping, so I'm just going to redraw that green circle from the oxygen. And we're going to say that it's sharing with the hydrogen. So now hydrogen is happy because it has, I'm going to draw a circle to show how they're sharing. So this hydrogen is quite happy. It has the 2 that it needed to have a full valence. And this oxygen right here is not completely happy because it only has 1, 2, 3, 4, 5, 6, 7. It's missing 1 more. So what I'm going to do is actually going to get 1 more hydrogen. And then let's just use this one that we had from before and put it in here. And then remember there is that 1 down here. So I'm going to add that 1 back in. Remember this 1 hydrogen was happy, had the 2. Our second hydrogen is happy as well. It has the 2. And now our oxygen is happy as well because it has 2, 4, 6, 8. So I'm going to just draw this to show that it's sharing. And everybody's happy. They're all sharing. They all have a full valence. They're stable. And then our last step is to show our molecular compound. And that's basically the same thing that we've done here, minus the sharing dotted line circles. There's a few ways you could draw it. Draw it in a straight line like this. Or you can draw it like this. Water's kind of like, it kind of reminds me like a Mickey Mouse with like the head and the ears. It doesn't really matter how you draw it as long as we can see that these electrons are being shared. And I realized that we need to add 1 more here. So here there's 8 and 2, and we're good. And that's it.